Assalamu alaikum, my dear students. Today we'll be performing an experiment called as Oersted Experiment. And in this experiment we will show that there is a relation between electricity and magnetism. It was first performed by Oersted in 1820, and he discovered that there is a relation between electricity and magnetism. For this you need three materials. Okay, one is the magnetic compass. This is the magnetic compass. Okay, and second you need a wire. This is a wire, insulated wire, and you need a battery or a cell. Okay, a battery or a cell which will draw current in the wire. Let's now do this. How to perform this experiment? You need a magnetic needle. This is the magnetic needle, and you need a wire. This is a wire, and I have a cell in my hand which is a 1.5 volt cell. This cell will draw a current in this wire, and then we will see what happens to this magnetic needle. Let me connect this wire to the cell. This is the positive terminal, as you can see here. This is the positive terminal, and this is the negative terminal. This is the negative terminal, and this is positive terminal. I connect one end to positive terminal. As you can see, I have connected one end to the positive terminal, and I will connect second end, the other end, to the negative terminal. This is the negative terminal. Firstly, I will show that when I bring this wire close to this magnetic needle, without having current in this wire, there is no deflection. As you can see clearly, there is no deflection. I have brought this wire close to this magnetic needle. There is no deflection, as you can clearly see. When I connect this wire to this cell, which is 1.5 volt, there is a current in the wire. The current generates in the wire. Okay, the current is generated in the wire, and when I bring close this wire which carries current to this magnetic needle, as you can see here, it deflects. It gets deflected. You can see here clearly the magnetic needle gets deflected. This is the deflection, and the deflection takes place from north to west. Okay, if you focus on this end, north end, you will find that this needle gets deflected towards west. As you can see, this magnetic needle gets deflected towards west. Okay, so this was positive end and this was negative end. Now what I do is I will reverse this battery. I will reverse the current. Okay, I will reverse the current. I have reversed the current in this wire, and you will also see that the deflection gets to the opposite end. See carefully, the deflection gets to the opposite end. Firstly it was towards west, and now it is towards east. As you can see, the deflection gets towards east. Okay, So what is the phenomena? Why the magnetic needle gets deflected? So this experiment shows us that whenever there is current in the wire, this current generates the electric field in the wire. Magnetic field in the wire. Okay, the current generates magnetic field in the wire. Whenever there is current, there is magnetic field. Okay, so from that experiment, Oersted showed us that whenever there is current, there is magnetic field. So so the magnetic field which is produced here in the wire is the reason why this magnetic needle gets deflected. So magnetic field will attract or repel the magnetic materials. Okay, so this is the reason. The reason is electric. This current generates here magnetic field. That is why this magnetic needle gets deflected. And why sometimes it is deflected towards west and it is deflected towards east? When firstly there was the current from this end, the positive to the negative. Okay, this was the positive end and this was the negative end. This means that the current, the conventional current, is from positive to negative. This means that current is from this to this, and the magnetic field is created. How magnetic field is created? That is given by right hand thumb rule. That's given by right hand thumb rule. What right hand thumb rule tells us? It tells us that you have to put your thumb in the direction of current. Okay, the current was from here, in the direction of current. The current was from this end to this end, so I put my thumb like this. Okay, if the current was from here to here, I would have put my thumb like this. But the current is from here to here, from this end to this end, so I put my thumb like this. And a magnetic field is given by these fingers. You have to fold these fingers. The direction in which these fingers are folded gives the direction of magnetic field. This is the direction of magnetic field. As you can see, I am folding these fingers in this direction. So this gives the direction of magnetic field. And magnetic field lines in this case are concentric circles. That means magnetic field is like this. Okay, we have to draw here the concentric circles. The magnetic field is like this. And now when I reverse this current like this, so I have to put my thumb like this, okay, in this direction. And I have to fold these fingers like this. The direction in which these fingers are folded gives the direction of magnetic field lines. Okay, when the current is reversed, so magnetic field lines are like this. Okay, firstly, the magnetic field lines are like in this direction, and secondly, the magnetic field lines are in this direction. This is the reason that this needle gets sometimes deflected from towards east, and sometimes it gets deflected towards west, because the magnetic field here is gets reversed also. That's why this needle gets deflected in the different direction.